学生让我说到下午4点，就很下午4点。
回转，请启出二口。
Okay, good morning to everyone. So this is already week 12, 11. So we still have a few more weeks to go before finish. We are expecting to finish faster. So if we finish earlier, then we might spend time doing some revision session to help you with your finals. So are you guys how do you guys find this class? Fun? Fine? Fun or fine? Can catch up and follow? Okay, if you cannot catch up or cannot follow, please feel free to let me know so that we can try and work out something that helpful to you. Why do I ask this? I saw that the number of submitting pages increase. Okay, so actually I wanted to ask you as well, how do you find your degree? Your degree, like other courses, are you surviving or not? Can you follow? Okay, although I'm not your degree lecturer, right? Because since I'm teaching you, so it's better that I know that how the students are doing, so that our department can offer better courses to you guys. Do you guys find your courses, other courses okay? Okay, still okay, still okay. Hard, is it hard? Very hard. Can follow and survive. Do you have help, or you just study yourself? Ah, no, no, no. So mostly you guys just study on your own. Do you like make a study group or what with your friends? It's pretty important to do that in university. Otherwise, you'll be on your own. Okay. Okay, in that case, we'll continue. So we'll recall the partial fraction method. So let's recall the partial fraction. Okay, so for integration by partial fraction, right, we will split into a few cases to do. So case one is the denominator is a product of distinct linear factors. Okay, I think I should move away from this table. Okay, so what do we mean by this? So, have like 1 over x minus a times x minus b, right? Okay, so you could split the factors inside your denominator, okay, into sum of terms, okay, with some coefficient. Okay. But actually, how do you determine this coefficient here? Okay. So the way that I asked you to do last time was by substitution, right? Substitution. Maybe consider x equals to a, x equals to b. Okay, to find b, for example, to find a and b. Okay, but if you just substitute here, what happens? Can you divide by a minus a? You cannot, right? Okay, so what's really happened here was you consider this function here. So you consider after you removing the the denominator. So removing is not like I just throw it away. Is that I multiply the factors across. Okay, so I multiply the largest factor. Okay, everyone can follow this. Okay, so basically we remove by multiplying x minus a and my x minus b on both sides. Okay, then you can do this x equals to a, x equals to b. And because it's why do we choose little a and little b here? Because it is the root of x minus a and or x minus b. So they will become 0. Or another way is so maybe I can show you another way what's really happening here. Because this is just this is so here the model is since it is the equation is true for all x, we just check on the two x's. But what you actually can calculate this in general. Okay, so what is in general here? So in general, right, what you're really doing was you are equating the two sides. So you are trying to equate the two sides here. So if you equate this two sides, right, let's write it in the same denominator form. So meaning you get them to have the same denominator on both sides. Okay, so what do you see here? So if you want to make this two equal, right, meaning what? The denominator is the same already. So you want to make the numerator equal. Okay. So meaning you want to make 1 equals to a minus b plus e times x minus a. Okay, this is the same thing that we get just now. Did you recognize? This is the same thing we get just now. But from here, I'm not going to use the substitution method. Okay, I will solve directly. Okay, what do you mean by solve directly? So for example, I could factorize the x, okay, and then I keep all the constant together. Minus a, b, yeah, let's see. Okay, but you can see that on the left hand side, okay, there's only constant, there's no x's. Okay, so meaning what? This term have to disappear. Okay, so if you want to make the a plus bx disappear, what do you do? This means that a plus b must be equal to 0. Okay, so 0 times x is 0. And then you want to keep your constant part. So meaning minus ab minus ba have to be equals to 1. Okay. If it is not clear, maybe I can write something more here. Actually, what you are doing is 0x plus 1. Like that. Okay. Okay. Then what do you get here? So you get a actually equals to minus b. Okay, so if you put this on the other side, what do you get? bb minus ba equals to 1. So b equals to 1 over b minus a. Okay, so this is the general formula here. So what we get is 1 over x minus a times x minus b is equals to minus b over, so we have the b man, right? 1 over b minus a, x minus a, and then plus 1 over b minus a times x minus b, like that. Okay, so this is the general formula, for example. Okay, so meaning your constant a, b, right, depend on your root, actually. Depend on your root. You believe or not? You want to try an example? So for example, we can try an example here. Let's say x minus 1 and x minus 2 here, right? So if I follow this formula, right, what do I get? You can use the substitution method, the 0, and then compute it, or you use this formula here. So b minus a, you get 2 minus 1 in this case, so you get 1, which is x minus 1, and then also second. Okay, maybe you can verify whether this is correct. Can you quickly verify this? Verify this. So, for example, minus x minus 2 plus x minus 1, and then over x minus 1, so x minus 2, which is equals to minus x plus 2 plus x minus 1, right? So, left with 1 in the. Does it make sense? Yeah. Question? Any question? Okay, so anyone know that why we want to split it up like this? Anyone know? You know why we want to split it up like that? What's the advantage of splitting up? X squared? What do you mean?
If you don't
Mm. Mm. Mhm.
why?
Mhm. Degree 2.
Yeah.
Okay. Okay, so complex. Complex, you mean the English word complex or the complex number? Difficult. Okay, good, very good. Okay, so the original question was we want to integrate this. Okay, we want to integrate this, but I mean, if this denominator appear in the numerator, it's okay, right? You can integrate term by term, but this thing happen in the denominator is very hard to do. Okay, instead, we will split the integral up because we know how to integrate 1 over x, for example. The integral of 1 over x is log x. Okay, so you can use substitution to make this into 1 over y. Does that make sense? Yeah. So this part, this integral on the right hand side is e. Okay, on the left hand side is r. Okay, so that's why we're splitting. Okay, because these are just log x minus a, for example, this one log x minus b. Okay. Can follow? Question? Any question? Feel free to ask. Okay. You go back, no one to ask. So you must come here and ask. Okay. Yeah. So then last week we stopped at the second case. So what's the second case here? So case 2 is the denominator might have some repeated factor. I cannot say have. Maybe just constitute of repeated. Okay, maybe can. Okay, has repeated. So what do we mean by this? So for example, look at this following question. 1 over x minus a squared. So maybe you might guess that maybe I just split it to a over x minus a. Okay, and then you follow the substitution rule that we discussed just now. Maybe you get something like 1 equals to 1 equals to a, and then you say let x equals to a. Okay, and then you say that is it enough? Oh, and this time, right, you cannot determine your a. Oh, okay. For example, maybe you can let it be minus a, for example, right? If you link it by minus a, then you can find your a, right? Because it is 1 over minus a. You say that, oh, then hence 1 over x minus a square equals to minus 1 over 2a times x minus a. Then you start integrating. Correct or not? Is it correct? Do you think it's correct? You think it's correct? You found the capital A constant and then you start integrating. Anything wrong here? So it's last line, correct? So where's the problem? Sorry? Where's the problem? If all the step is correct, you know where's the problem? The problem is from the start. Assumption is wrong. Okay, so meaning the green part here is wrong. This is wrong. Yeah, this is almost never right. Okay. So what is right is you need to take an extra term, okay, such that you add up to x minus a squared in your denominator. Does it make sense? Okay, so if you have repeated root, then you need to consider from the low degree up to the highest degree. Okay, because just now you are just distinct linear factor, right? Linear factor means what? The degree is 1. So that's why you only split to 1. Okay. If you have repeated root, again the degree is 2, then you need to add up to the second degree here. Does it make sense? Okay. Right. Okay. So similarly, you can do what I did just now, right? So in general, what happens here was if you start with 1 over x minus a squared equals to a over x minus a plus b over x minus a squared, right? So what happens was you can simplify it first times a times x minus b, right? And then can you find a, b now? Okay, so then right. So then we can use the substitution method. Should we use it? Here. This one disappear. This one I guess cannot disappear. Okay, so we can use the method that we learned just now. So let's say ax, we split out the x term, the degree 1 term, and then we split out the constant term, right? So there's no x's on the right hand side here. So a has to be equal to 0, and then minus a. So capital A times little a plus b has to be 1, but a is 0, meaning b is equal to 1. So very makes sense, right? Because 1 over x minus a squared equals to 1 over x minus a squared. Very trivial in this case. Right. So how about oh, this is one way to do it. Let me see if there's another way. What if we use a substitution? So maybe this is the first method. Then let's say use the substitution method that we know last time. See what happens here. So again, we start from 1 minus a times x minus a plus b. So okay, x equal to a, b is still 0. B is still 1. Did I get anything wrong? So let's see. Oh, okay, makes sense. Okay, good. Okay, so this is the easy case, right? So B has to be 1, and then if B is 1, what is your capital A? So you can rewrite equation 1 equals to ax minus a plus 1. So a equals a times x minus a is 0. So this implies that a equals 0 or x minus a equals 0. Okay. But x minus a is not always 0. So a has to be 0. Okay, so this is the easy case. Okay, so can you try and do this question here, the harder case? Okay, try and do this harder case here. So that's why there's not one in the numerator, it's an x. Okay, so there's a non-trivial splitting. Okay, I give you 2 minutes to work this out. I think last time we worked halfway already, but can you try and verify this solution again? Yeah. The point of mathematics is like you redo, you get the same answer. This is a bit like science when you do experiment. Okay, you hope that your conclusion is right, your result is right. So you will redo again. Okay, see whether something. Okay, try and split it up and verify it. I give you maybe 1 minute. And then we'll continue with integration on this integral. Okay, everyone happy with the splitting? Does everyone got this splitting rule? Okay, if everyone got this splitting, then we can continue with integration. So, right, x over x minus 3 with 2 equals to 1 over x minus 8 minus 3 plus 3 over x minus 3 squared. Okay, so something very interesting happened. Did you observe? Did you observe something very interesting happen? The numerator used to contain a degree 1 x, but after you split, become constant. The numerator. Okay, but at the expense of extra term here. Okay. Can you see how this x can pop up? Can you roughly see how this x can pop up after you add these two things? Because when you equate the denominator here, right, you need to multiply x minus 3 factor on this first term. So the x here will survive. It will survive. All right. So this is a good thing, but why is it a good thing? So let's try and do integration, then you will see why is it good. So if you're gonna integrate x over x minus 3 dx, so this is equivalent to splitting up the function. Okay, but we know that integral is linear, so we can do integration term by. All right, so for the first one, I think we know very well already. This is ln x minus 3. So if you still don't know how to get this, you should do some substitution. For example, y equals to x minus 3, and then dy equals to dx. How about the other one? The other one is also substitution, okay, but then the substitution here, again, we just substitute w equals to x minus 3, okay, such that dw equals to dx. But this substitution here, instead we get ln, right, it becomes 3 over w squared dw like that. Okay, so what it happens is just reducing the power in the denominator. For example, like this. So you can substitute back your substitution. Like that. Okay. For some constants. So far, so good. Okay. So you could do this, the integration on the right hand side, but this left hand side here is kind of difficult. Sometimes you want to use integration by parts, right? Or maybe you use trigger integration, trigger substitution. But those are very complicated. So you can see that right hand side is very simple because you turn things into polynomial. So polynomial is the most simple function you should think of first. Integrating polynomial is simple. Yeah. Okay, so far any question? Any questions so far? If no question, let me see. Okay, how about do this question? I give you 3 minutes. You solve everything until you solve to the end, until the integral. Okay, do the partial fraction and then do the integral. I give you 3 minutes. See if you can rush yourself. So this exercise in class is very good training for you, so that you can do quickly inside your quiz or your exam. Let's try and push your limit. Because last semester I was teaching the short sem. So during the short sem, I think you will be encountering short sem in next February. So those courses are like 5 weeks. 5 weeks you need to finish one course. So almost like every week you got the 3 classes, 3 same classes. Okay. So for example, last short sem I teach linear algebra. So it's like 14 weeks become a 5 weeks thing. So in that class, there are various students because you need to take outside your. So for example, your science students you need to take arts, like arts in that science. So they are coming from finance class. They are not very good in maths, but they are interested. So usually GE you take interested courses. So in that class, right, I force them to do linear algebra, like what you learn, like eigenvalue, eigenvector, those stuff, right? There's a quiz, right? And then I ask them to do in really 10 minutes of the exercise, really 1 minute, you need to calculate your eigenvalues. And then he said that, oh, after that class, in the long term, they need to take a maths course called Shooter. It's like a mix of calculus and then he said, oh, I'm very lucky to take your class because I can calculate faster than my classmates. And so if you try to push yourself, learn as much as you can, you will gain a lot. And then she said that, oh, she find that the statistic old stuff is very easy already. Oh, okay, so make sure you learn within the class. Okay, it will benefit other classes as well. Wow, I taught so many. I think 3 minutes passed already. Gives you a bit more time. Okay. Anyone got final answer? Anyone got final answer? Oh, say you got it. Sorry, you just get a partial fraction. But second, you get a ABC. What do you mean A and B? Huh? What do you mean A and B? You get the partial fraction only? You final answer is after integration, right? Okay, wait. Let me see. What do you get? 22. Then ln x plus 3 absolute value minus 2.5 over x minus 1 like that. That's it. Anyone got this? Or you got a different solution? What do you get? Yeah. Jeffrey, you want to try? Okay, so what do you get? Ln absolute value x plus 3 then plus 2 times ln of x minus 1 and then plus 10 over x minus 1 plus e. That's it. Okay. Anyone got this or different solution? You got different solution. Okay, let's try. 4 times ln absolute value. Okay, please remember absolute value. 1 plus minus absolute value of x minus 1 minus 1. Okay. Others? The fourth solution. Any fourth solution? Okay, so the nice thing about mathematics, right? Only one solution should be correct. So which one is correct? Anyone agree with one of these? Or you get one of these solutions? You got the green one. I also got the green one. So most probably green one should be correct. Okay. So maybe you are correct in doing your integration. Okay. Then the problem could be lie in the partial fraction. Okay, you need to check whether your partial fraction setup is correct or not. Okay, so let's discuss the setup of your partial fraction. Fraction. Right. So how many constant here you need to consider actually? How many constant? Okay, so let's see how many factors you have here. Okay, so how many factors do you have? So you have actually two distinct factors and then one repeated. Okay, so how do we deal with the distinct one? Do you still remember? We just split them up. Okay, but the repeated, what do we need to do? We need to add all the degree up to the highest degree. Like that. Okay, so this is the setup you need to start with. Okay, does everyone start with this? Okay, so after you start with this, then try and remove the denominator so that you can do a proper calculation. Okay, is the second step the same or not for everyone? Is everyone the same at the second step? Okay, so once you reach to this step, then you just need to consider three cases. For this case, it's easy. X equals to 1, x equals to minus 3, and x equals to. Okay, then you will get your so you'll get your C first, and then you'll get your A, and then you'll get your. So looking at this ABC, which solution is more possible? Which solution is possible? So if you look at this ABC here, A is 4, B is minus 1, C is 2. So you can see that the 4 appears here, minus 1 appears here, 2 appears. Okay, ano? Okay, Jose. Okay. Jeffrey, got it? Okay. So if you have this kind of number appearing, right? So I will just suspect this is your A, I don't know, 22 over 0.5 would be your A, and then 2.5 would be your B, I guess. Right. But you are lack of one term, or are you missing one of the partial fraction? Or missing which one? Yeah, the C's, right? At the start in the class, I already remind you, you have to go to the highest. You cannot just stop there. Does it make sense? Okay. So another thing in the lecture is you need to listen very attentively to your lecturer. Okay, I know maybe some good lecturer, like what the students don't know what they are talking about. But what I taught in this class, right, you have to try and listen, okay, very carefully. I'll try and give you as many advice as possible. Let me look at Jeffrey's solution. I think Jeffrey's solution is the ABC. Maybe just calculation of ABC is a bit different. For example, your A is not 4, and then your B becomes 2, and then your C, you need to check your calculation again. Okay, so these are the minor mistakes, but you need to be careful that sometimes, right, because you are in an applied field, okay, because you are in an applied field, the accuracy becomes very important. So maybe your integration is correct, but at the start you already have mistake. So your final solution is wrong. So it doesn't mean that all steps are wrong, but there are mistakes inside that you need to identify. Okay. Okay, good. So let's see what's next. And how about we try one more? Okay. Just try and split it up. No need to do integration. The integration of this is very easy. Try and split it up. Okay. After this question, we will take a break. Yeah, just try and split this thing up. I give you 3 minutes. Try and split it up. I can take some record for your project. Yeah, Ting here or not? Oh yeah. Chen Fan. Chen Fan, you decide on your topic already? Newton's method. Okay. Is it the one finding roots? Finding roots? Okay. Wu Ye, have you think of your topic? Yeah. Haven't. Okay. Try give me on Friday. Hong Liang, are you in a group yet or you yourself? Do it alone? Okay. Have you found your topics? Haven't? Okay. Try give me on Friday. See her there. How about see her? Yeah. Do it alone. You do alone. Okay. You fix your topic? Not yet. Le Tian ne? How about Le Tian? Chen Le Tian here or not? Chen Le Tian. Luotian is in which group? There's a group 6 here. Yan. Same group, is it? Have you guys fixed your topics? Not yet. Who is your leader? Fixed already? Not yet. Yeah, try and fix one on Friday, okay? Okay. So let's check. Anyone managed to factorize your denominator? Anyone managed to do that? How do you factorize it? So this is the degree 3, right? So you might be expecting 3 factors. Okay. So how do you find the first factor, for example? I guess you need to guess. Or because this is the 1 at the end, right? So how do you get this 1 if you split into factors? This is just multiplying the constant together. So how to get 1? Well, you multiply -1 or you multiply 1 together. Okay, so you need to guess whether 1 or -1 is the root or not. But how to guess? You substitute. Okay, you substitute 1, do you get 0 or not? You substitute -1, do you get 0 or not? Okay. So in fact, when x equals to 1, 1 cubed minus 1 squared minus 1 plus 1 is 0. Okay, so this is one of the root. Okay, so meaning you can do long division. Okay. X minus 1. And so meaning you can do this long division here to help you find your root. Here, x cubed x squared, and then minus x plus 1, and this is pretty straightforward. Okay, so we get x cubed minus x squared minus x plus 1 becomes x minus 1 times x squared minus 1. Can you further split x squared minus 1? Can you do that? Wait, what am I doing here? Did I do something wrong here? 1 minus 1. No, right? Yeah. Fine. Okay. Can you further split x squared minus 1? It is a difference of 2 square, right? A square minus b square. A square minus b square becomes what? X minus 1 times x minus 1 plus times x plus 1. Okay, so actually, how many distinct roots you have? Actually, you have 2 distinct roots, but with 1 root repeated. Okay, so this is the similar case we had just now. Okay, so we will consider big sum here in big fraction equals to sorry, should we split it first? Maybe split it first is easier to see, okay? So we know what we're doing. One here. So we will split it up to a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. Did everyone split out like this? So until this stage, we should be agreeing first before we continue. Okay? Everyone got this stage? This stage, okay? Okay. Once you got this stage, then what we do next is we consider removing all the denominator so that it's easy to compute. So we get a times x minus 1 times x plus 1 plus b times x plus 1 plus c times x minus 1 square like that. Okay, okay. Then a few very easy substitution you can think of. So for example, you can take x equals to 1, and then x equals to minus 1, and then x equals for the first one is easy, you can get let's see which one you get. Yeah, you can get b first, and next one you can get c, and then final one you can get a. A is 0. Okay, so in fact you only start with these two terms. You only need to do 2 integration. Okay. If you look at these 2 terms, you roughly get what's your integration. So this term you get to log x, absolute value of x plus 1. This one, it's just 1 over x minus 1. Okay, because okay. Anyone get until this section? Oh, Xiangsi got it. Okay. Yeah, you can continue with your. Yeah, any questions so far? Any question? If you found any mistake in my calculation, right? I mean, for the lecture notes, you can contact me as well. Okay. And okay. So how about we take a break until 11:04? Okay, we come back with a third case. Okay, meanwhile, we will check your project. Is Le Tian just come in? Le Tian, you just came in? Okay. Make sure your group find topics by this week. Friday. Okay. You haven't submitted your quiz, what happened? What? You don't want to? Huh? No, you don't have chance to submit anymore. You missed the submission. We are not allowing late submission. So why are you not submitting? Maybe you can talk to me when you are. Yeah.
So, as we know, like,
Same one. This is the same.
okay,
Yes.
so, like, when it comes to like a, you should, times this one x minus 1 square,
Yeah, sure.
and then so why there is no square, like
No, because there's a x minus 1 here, so cancel. So actually, you are multiplying this across. You understand? You multiply this factor here across everyone. So there's a x minus 1 here, cancel.
but you ignore the there's no this one is also no number below.
No. So do you know how to like multiply denominator across? Kind of like, for example, right? I want to remove this denominator. So what I should do? I should apply every terms by this denominator. So if you apply this x minus 1 square times x plus 1 with 1 over x minus 1, what do you get? Surely x minus 1 will cancel. So that's why you're left with these two. Yeah. But
This part you just ignore the so
no. Okay. I think you don't get one. So what I do was I just multiply like this is called multiply. It's for things, right? But there's only one thing.
Microsoft is syntax. You divide it, the number. I don't know how to say.
Yeah.
But just you time.
Yeah, multiply. Say, why did you not submitting your this? You forget.
Yeah, something.
Cannot. Yeah, allowed late submission.
Okay, last question.
Okay.
Trying to figure it out.
Oh, okay. So then you missed the deadline.
Yeah.
I see.
It's totally I can show you by
Sure. But yeah,
who would have like
I mean, maybe you just missed that part of the quiz marks. So maybe around 4%. 4%. Yeah. It's quite a lot, but not a lot, but somewhat a lot. But then again, if you think from 100 point of view, maybe you're missing. I feel 96. So you've got some room, but not many room for you. Totally for me. Yeah. So you need to keep up your time zone. Okay.
So many tips.
So many. Yeah, I understood. That's why just now I asked you guys whether you can keep up with all your works or not. I understand. So you need to. Okay. Yeah.
这个是 X 四啊？什么啊？你说什么？你讲为什么这个是 X 的四次？对啊对啊，那右边怎么出来 X 的四次方？这边最高其次就有2次，最高项就有2次。
来看啊。
它这种四次方
33，是不是我做错什么东西啊？
不是啊，反正我不是这样做的，因为
对，你不是这样做，我做错，我知道我做错了。
是 X 四次方，就是得先
对，
把
你讲对，
把它那个上面那个
你
像素
讲
画下来。
的对，但是我想下，我应该是有什么东西。对，我错了，我想下。
不是你这一步它不这一步都不成立了，这一步。
对，我知道，对，我知道，所以我讲我错。我明白。
我知道了。
对，但是我想一下，怎样调整它？怎么调整呢？
你把那个提一个 X 加1出来，
就从上面呢，你
就是你要先把这个4次画掉，画成3次，然后你发现3次还是不行，然后你又把它画成2次，然后最后就变成了这个十字可以化简，
可以化简啊，
就是它变成了 X 加1再加上
你刚才讲的是对的，这个我做了刚才我讲的那个错误的东西出来。
一的时候可以放，就是把这个他把一个 X 提一个 X 出来，把这个4项全部消掉，然后就变成了一个3次，然后你再提个1出来，你会发现上面变成4X，然后可以做3，就这个提一个 X 出来。
哦，你是说？你的意思是说我这个拿来除它，直接除？
不是除，就是提一个 X 加1。先提个 X，就下面就把那个4项全消掉，4次方消掉。
你是怎么做到这件事情？从做到这件事情，是这个，做了什么东西？
就把这个十字化简，提了个 X 出来。
这个怎么换？我想想。哦，我想想，怎么你把一拉出来过后，你这边还是一呢？你有问题？哦，因为我拉的是 X，哦，所以 X 会改变吧？啊，make sense。
然后你发现上面3次还是你再提出来个1的时候，你就变成4X。
啊，OK，我觉得你合理，全合理。这样我这个东西做了东西，
哎，这个你是不对的呀。
对，这个就犯了我刚才最大的错误。Yes。Attendance first。两遍了，若是施曼，一男，OK，玉涛，一则，例文，例文，泽汉，呀，加来，加成和加成，哦，加成 and 玉衡 not here，嘉怡，齐军，黄齐军，一清，君毅，相思一林，冰珍，and then 加糖，浩云的文琪个康祥个杰呢，我团的新阳，万达新月，玉衡，also not here，一田，马一田，OK，冰城，然后冰城，浩然 浩然你没有教记错时间啊，严重耶。Desmond Tommy 创意 yeah 安妮姐Gopagani let's go Pagani okay Actor yeah Jose got Hisham yeah Daniel yeah Hashim Big Yusuf Hashim okay Madia yep Aaron Brandon Felicia Gunakanti that's Gunakanti not here Margaret yep. Javed not here Gabriel yeah Jeffrey yeah Purity yeah okay so on Friday please give me a name of your leader and then who else and then topics okay by Friday this Friday later on your leader will be submitting your presentation right all right so Jun point out a very good question here is it possible this line is correct or not? Is it possible this line is correct huh? Is it possible this line is correct so I think we make a very big mistake like what I said at the start in the class right okay so where's the mistake here if on the right hand side huh, the highest degree is 2 left hand side the highest degree is 4 where it's impossible to build a degree 4 part right so in this case how to solve it how to solve sorry huh? Separate the constant what do you mean out divide low okay so for example like in fraction what happened in fraction right for example let's think about some fraction let's say 6/8 okay so to write this 8/6 right maybe you could write it as 1/2/6 first only then you write it 1 plus 1/3 so what I meant here is you try to make your numerator okay as a smaller degree than your denominator before you split before you do the partial fraction okay or not? So you remove as many denominator outside out from your um, fraction okay. So is it possible to do that can I remove x cubed minus x squared minus x plus 1 out first can I do that or not okay so how do I do that okay, the problem is how do I do that okay so the first step here root is still okay but here is this equation here is this is rubbish okay, let's remove this rubbish here. Jingji, you can so that we don't need to continue this rubbish okay so we got this split here but now we're gonna higher degree up from our numerator here so I'm gonna remove here right so how to remove this okay this is a technique here okay so let's do it x to 4 okay. So x is 1 over x cubed minus x squared. Okay, so let's see how we're gonna take one denominator out first. Right, like one way is like what how run say do long division. Okay, so let's do long division. Very straightforward. Long division here. Okay, so we split out the higher degree term out first. So do long division, you get x to the 4 minus cube squared like that, right? And then you get x cubed minus x2x squared plus x squared, you get minus x squared plus 4x minus x, you get 3x, then plus 1. Okay, can we further do? Okay, we can try one more, maybe plus 1. So 1 becomes x cubed minus x squared, or here minus 1, x1, right? So we left with 4x. Okay, so in the end, you can split out as x plus 1 plus 4x over x cubed minus x squared. Okay. Everyone can follow this? This is your integer derivative, right? Right, for example, 100 over, let's say, hey, over 21, right? So what do you do? So you do your 21 over 100 and then multiply by 4, for example, 4, 8. And then here you get 16. So become 4 plus 16 over 20. Correct? Make sense? Yeah. Okay. So from here only you do the ABC that we did just now. Then from here you do the partial fraction. Does it make sense? Okay. So maybe we left it as a homework. So go back and work it out. What's this? And then in the end, you need to integrate the whole thing here. Okay, so this term will go to x squared, right, over 2. And then this term will go to x, and then this term depends on what you get. Okay, any question so far? Is it we computed 4x before? No, no. Different. Okay. Jingjie, okay? Alright, Jingjie. Okay. Let's go to case 3. Okay. So here's case 3. So let's mention the case 3 first. The case 3 will have the denominator contain what we call the irreducible quadratic. Okay, irreducible quadratic factor. This means okay, quadratic differences. Okay, and then also none of them is repeated. I think we won't go beyond case 3. So these are the 3 cases you need to take it. Okay, we won't go beyond case 3. For example, you can ask, what if the irreducible quadratic factors have repeated? Okay, we need to solve differently, but we don't go beyond that. Okay, so we just stop at this stage. Okay, so meaning you have this kind of quadratic x squared plus 1, you cannot split into linear factor anymore. You cannot split, correct or not? Because x squared plus 1, there's no real root. No real root, correct? If there's a root that satisfies this, what does it mean? I squared equals to minus 1. That's the complex. Okay, no roots here. Okay, you cannot split anymore. Okay, so how do we deal with these cases? Okay, so the technique is here. So the technique is 6x squared minus 3x plus 1 over 4x plus 1 plus x squared plus 1 equals to, again, you split out the linear factor first, okay? But for the irreducible, you not need get one constant on the numerator. You need to add the lower degree term in, okay? So instead of just b, you need to put a bx plus c, okay? Because there's no one producing the lower degree term for it. You need to produce yourself. Okay, so there's a bx plus c on top of this irreducible quadratic factor. Okay, makes sense? Yeah. Yeah. Okay. So we continue doing this. We get 6 squared minus 3x plus 1 equals to a times x squared plus 1 plus bx plus c times 4x plus 1. Okay, you can use the method that I have just now, meaning you add all the S squared term together and then you compare by coefficient, or you use the substitution method. Okay, you can try. Should we try both? You want to see both? What happened? Okay, maybe you can try both together, so that to make sure we really do it right work, not like just now. Alright. Okay, so let's do the substitute version first. All right. So to do the substitute version, so obviously we will go and find out the root first. So for example, x equals to minus 1/4, and we get something like this. You can verify my calculation. So this will be, a will be just 2. Okay, and then next we will make b disappear such that I get 1 plus 1 equals to 2 plus c, which implies c equals to minus 1, like that. And then the next one will take x equals to 1, and we will get this b minus 1 times 5, and then we get b. So this is the substitution method. What if we expand it? So let's say this is the first method. Let's say, what about I expand it? So let's see what we get. Alright, so should I expand first? Okay, let's expand first. Expand. Then I group the x squared term together. Okay, so you can see like linear algebra popping up. Soon you will see. Okay, so you can see that I can set up 3 linear equations. Okay, so for example, a plus 4b equals 6, right? B equals to b equals to, b plus 4c equals to 3, and then a plus c equals to 1. Hey, why I got small b and small c here? They all have to be big C, right? So I think I put an extra variable in. I should make them the same. So this B actually is the capital B. So this is the capital B, then this is the capital C. And like that. Okay. So you can see that there's A, B, C, right? 3 variable, 3 linear system equation. How to solve? How to solve this? Recall your linear algebra lecturer again. Okay, we can do it together. Now, this is by solving like 1, 4, 0, and then 0, 1, 4, and 1, 0, 1. Solve this augmented matrix. Can solve or not? Once you solve this, make sure you get this 2 minus 1 and 1. Okay, maybe now we already got the answer, right? We can just verify it. Can we just verify it? Okay, you know how to verify or not? Or just take this matrix, multiply this vector here. Do we get 6 minus 3 and 1? So for example, we get this 1, 1, 4, 0. 0, 1 is 1, right? Okay, you multiply by 2, 1, 1. Is it true that you get 6 minus 3, 1 or not? Check. Is it true? Seems like we got the sign stuff wrong, right? A, B, C. Okay, I arranged it wrong. So here is 2, 1, minus 1. Okay, multiply. You get 1, 2, 1 times 2, 2, 4 times 1, 4, 0 and minus 1, 0, 6. Good. And then 0 plus 0. And then 1 minus 4 got minus 3. Good. And then 2 plus 0 minus 1 got 1. Good. Okay. If you don't have this factor here, you have to go and row reduce it. Okay, go and row reduce it. Okay, so far, any question? Yeah, I think this is the safest way. This is the safest way. So substitution one, very rely on the first assumption is true or not. Okay, like what we did just now, right? We start from the wrong assumption, then you might get ABC, but you already start from the wrong assumption. Okay, but this method here will always make sure that it is equal because you are comparing the right degree of polynomial. Yeah, like what just now happened was I don't have degree 4 on the right hand side. How is it possible to equal? So if you go down this route, right, you will never go wrong. This is what I want to say. Yeah. Okay, question? Any question? Any questions so far? We just split it up, huh? We haven't do integration yet. Shall we do integration together? So let's write down some partial fraction. So all together we get 6x squared minus 3x plus 1. A is 2 over 4x plus 1. B is x. It's 1, so x plus minus 1. Okay, so this is our partial fraction. Now we're going to do integral on it. Integration. Okay, so we can split out the integral into two parts. Integral into 2 over 4x plus 1 dx plus integral of x minus 1 over x squared plus 1 dx. Do I have sign problem here or not? T is 1, C is minus 1. I think there's something wrong with my notes again. Okay. Let's continue. Do you know how to do this integration? Maybe the first one is easier, right? First one, 4x plus 1. How about the second term? Is it possible to do any integration there? There's no more partial fraction you can do now because the root is irreducible factor, so you cannot factorize any. Okay, so what to do here? Well, is it obvious how to integrate the first one, or should we do it together again? It's obvious, yeah? Not obvious? Obvious, okay, kind of obvious. So maybe you just let u equals to 4x plus 1, right? And then du equals to 4dx, and then you do the substitution. You should get something like write down the solution and then see if you agree or not. 1 over 2 of ln of 4x plus 1. Okay, because there's a 4 popping up here, so it will be divided by 4, so 2 divided by 4. Okay, how about the other part? Hey, so this part, can't really use trigo, right? Because to use trigo, you need a square root of a square minus x square like that, or plus x square. You need a square root because you need to build your Pythagoras triangle, right? So a, for example, ax and then on the other side get like a square minus x square root like that. Okay, but there's no square root here. So what we can do is we further split this fraction. We can further split not by partial fraction, it's just the usual fraction split like that. Okay. So then this term is easy. Why is this term easy? Because the numerator is the derivative of the denominator. So meaning you can do substitution here. Okay. But this term, what is this? X squared plus 1. But this term here, there's a ready integral. What do I mean by ready integral here? So actually this integrand here is a derivative of something. If you can remember. If you cannot remember, you can go and check your paper. But maybe a bit of heads up is in the exam we will provide you some trigo, either integration or derivative, so that you know the hard. So meaning this part we already know. This is equals to tangent tangent inverse x. Okay. Because we know that differentiating the tangent inverse x equals to 1 over x squared plus 1. Any memory? No. Maybe we can verify this quickly. Tan inverse, I think, is the last thing we learned in the here. See? Okay. Maybe you need to be a bit what? A bit attentive to these. But for these two, you can still recover using the trigo substitution because this is in the form of 1 over square root of a square minus x square. You can use trigo integration to do it. But this one slightly hard. Unless you realize it as a square root of this thing square also. Unless you can realize that. What I meant was you realize it as 1 over square root of square. Then maybe you can try and integrate this. Can you try and integrate this as an exercise? Try and integrate this using the trigo substitution. Can you try and do this? See, can you recover tangent inverse x? Try and do this. You know what substitution you need to use here? What's the substitution you need to use here? So this substitution is, I guess, 1x such that you can get 1 plus x squared. Right? So maybe you can use tangent, right? Tangent theta equals to x over 1, opposite over adjacent. So such that this thing will be equals to 1 over square root 1 plus tangent square theta, right? And then everything squared. Basically, what you get? 1 plus tangent square theta is what? Secant. Secant, okay. So secant square theta, but you take a square root, right? So then you get back your secant, but again, you need to square it back. So you get a secant square theta dx. Or this is just a cos square theta dx. Yeah, then you continue. Yeah, continue. Yeah. If you get it, maybe you can let me know. I think you should proceed with your double angle formula. Double angle formula. Oh, I think I missed something, right? Because you have to get your derivative change, right? So dx equals to what? Dx equals to, I cannot remember. Secant square. Wow. And this? Is it this? Okay. Wow. So then this is good, right? Because you can just cancel. Mirror. Good. So, wow, this is very fast. Tangent inverse x. That, right? Because this secant square theta here cancel with your secant square theta, you get what? So you get theta. But what is theta? Tangent theta equals to x. So theta is tangent inverse x. That. We did the exercise together. Okay, so get this already. I mean, this. Well, you need to know about the different people. Okay. What time? 11:30. So let's continue. Yeah, and then the middle term you use substitution. Okay. Substitution here, maybe v equals to x squared plus 1, and then dv equals to 2x dx. Okay, use substitution. All right. So far so good. So far so good. Let's discuss about this one. Okay, so for 7.37, we are not integrating it, but can you write down a full partial fraction decomposition? No need to find ABC. I think you need a computer to help you find for this case. Okay, so first of all, again, we have a warning just now, right? Because we need to make sure that our numerator have a smaller degree than the denominator, only then we can start doing partial fraction. Otherwise, we need to pull out the higher degree terms. So the bottom degree is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 10. Above is 3, so you can do partial fraction now. So you need to recognize, are there irreducible factor? Are there repeated roots? So are there distinct linear factors? So I give you maybe 1 minute class. Okay, try and write down the full form. Okay, how many constant you need to set? Okay, how many constant you need to set here? Maybe you can give me a number later to verify. Okay. Right. Okay, so how do we define, how identify these factors here? Okay, so obviously x and x minus 1 are distinct linear factors because x has root 0 and then x minus 1 has root 1. X squared plus x plus 1, can you further split it? If you cannot further split it, why? So you need to prove that there's no real roots. Okay, do you know how to prove there's no real roots? The b squared minus 4ac, okay, the discriminant. So if you take 1 square minus 4 times 1 times 1, then you get minus 3. So square root minus 3 is a complex number, so it is no real root. Okay. So you cannot split it anymore. X squared plus 1 already discussed already. This is a equation for complex imaginary. Okay, so this is an irreducible factor here. Okay, so what's the total number of constant you need? What do you think? How many constant you need to determine? How many constant you write down? Anyone? Felicia, did you try? How many constant you write down? 10. Okay. How about the rest? Jiatan, did you try? Never try. Not sure. How about Margaret? Margaret? Is Margaret here? Margaret online or not? Are you online? Don't leave the chat room. Well, how many constant you get? Don't know? How about guess? Mathematics, you need to start with guessing. That's what we call conjecture. Guess first. 5. Enough, 5 enough. Okay. Let me get another one. Yinan. Did you try? How many constant you need? 10. Okay, good. I think a lot of you getting 10. So let's see where's the 10 constant come from. All right. So let's see. So obviously we're gonna split x, right? 1 over x. Okay. And then obviously we're gonna split x over x minus 1. Okay. And so x squared plus x plus 1 is irreducible. So remember what we have to do to the irreducible? So we're gonna add 2 constant to include the degree below 2. Okay, so we need cx plus d, this term here. Right? And then how about x squared plus 1? So x squared plus 1 has case 2 and case 3 combined. What does it mean? So you have a repeated factor with an irreducible quadratic. Okay, so meaning what? So you need to repeat your irreducible quadratic case with your repeated factor. So repeated factor means what? You need to add up to the highest degree. Okay, so all together we need a up to j, so 10. Okay, so please don't try to attempt calculate this using your hand. You should use the. Actually, if you use a computer, right, the solution is not too hard actually. Maybe I can show you here. Actually, the solution is a very nice number. Where is it? Hey, wait, my. Where's my textbook? My textbook is gone. Here. Maybe try search for the textbook. Did you know that our questions are from textbook? Did you realize? You guys realize the questions are all from textbook? Hopefully, I can provide extra explanation than the textbook, so that you are not just coming to hear sound. Right. Where is it? 7.3. I find 7.3. Okay, almost. Okay, so here is the solution. Okay. It's not too scary, actually, the solution. It's quite nice fraction here. Okay. But try not to calculate using your pen. Okay? Alright. Oh, actually, you guys see it already. Just that I didn't see from my side. Okay, I have a Zoom version. Hey, why? Move this guy. Maybe turn it off. Wait, what's going on? Flash until I cannot read it. It's my wait, I think something wrong with my. Okay, so I have a bit larger version. Okay, this one. But it's not very scary actually, the number. Just that to find it is very tedious. So this is for this part here. Okay, how about let's do this final one, and then we can call for the day. Let's try this. Should I let you struggle a bit? Yeah, maybe I let you struggle a bit. Try and think about it. There's a square root there, huh? Very annoying. Is there any way to like change it? And then the square root inside there's no square, so you cannot use trigger substitution. Right, so there must be some way to do partial fraction. I'll let you struggle a bit more first. Okay, anyone managed to try something? Anyone managed to try something? Is there any way to convert this square root? Hmm? Any chance? Any breath solve?对啊，写下什么东西？哎，不清楚，没有算。你写什么？我要看你写了。写了什么？你做了什么？怎么换？你告诉我你换了什么？T equals to square root x plus 4. This is what I did as well. This is what I do as well. Okay, so if you make this substitution, what do you do? X. Or you want to remove the square root, right? Obviously, you can write t squared equals to x plus 4 like that. Okay. Then Then you need to get your substitution works. So substitution meaning what? You can get dx equals to 2t dt, whatever. Right? Everyone follow this? Right. Then you integrate square root x plus 4 over x dx becomes what? Integrating t over t square minus 4 and then 2t dt. Right. Okay. So then can we proceed? Yeah, we should proceed. So altogether we get integrate from t square over t square minus 4 dt. Right. You see? So the top degree, the numerator degree is equal to the denominator degree, meaning what? We can do long division here. Okay, so we can do long division. If you do it, you get 1 plus 4 over t squared minus 4. Okay, so you do something like t squared minus 4 over t squared. Okay, so 1 t squared minus 4, 4. So your remainder is 4. And then, so what do you do next? So first term, you know how to integrate. How about second term? It's a difference of 2 squared. So meaning you can split out the factor. So become t minus 2, t plus 2. Then the second term is very obvious to do partial fraction. Is it obvious to see what's the partial fraction from here? Is it obvious or maybe not obvious? Is it obvious how to do this partial fraction here? Maybe this kind of easy partial fraction you can directly see it. So maybe I can write it out for you to verify. Sometimes it's just by inspection. 1 over t minus 2 plus 1 over t. Is it correct? So if you cross multiply, right, e plus 2 plus e minus 2, so you get doesn't I think we need a half, right? Is half enough? Just now we computed the formula, right? Is half enough or not? Should we work it out? Let's see. U minus 2, U plus 2. We got a formula at the start. Let's check. One over B. Okay. Should we do step by step? Do step by step here. 1 over 2 equals to 3. Okay. Then with P equals to minus 2. And then B will be equals to minus 1 over 4. 2. And then A. Okay. Yeah, so this 1/4 here will be cancelling out with this. Yeah. So altogether we should get 2 times t and then plus t minus 2 minus log of 3 times 2. Okay, but we do the substitution. So we need to put back your square root x plus 4 into your t. Then different in ln we can do division, right? Okay, so on the top we have square root x plus 4 minus 2 over square root x plus 4 plus 2 like that. Okay, so this is the final form. Okay, does it make sense? Okay, so you integrate a square root term over an x term. What do you come out? You come out with the numerator plus some ln term. Okay, any question so far? Question no? Okay, so this question here kinds of like mix substitution with partial fraction together. Okay. All right, if no question, we'll see you on Friday. Then please decide your project question then, project topics. And then for those that haven't found your group, right? Please found your group as well. Otherwise, you might have to do alone.